Hello everyone, welcome in this educational video. Today we are going to learn about electricity and different terms regarding electricity. Those are current, voltage and resistance. Before starting this video, I would like to inform you that this channel regularly uploads the video regarding informative and educational content of science. So if you are interested, then you can please join this channel. So today we are going to learn about electricity. Okay, how electrical current flows in a circuit and current, voltage and resistance. Okay, these terms we are going to learn today. Okay, any appliances that we use in our daily life needs electricity. Okay, for an example, washing machine, TV, fridge, these all appliances need electricity. So from where the electricity comes from, okay, we need to learn about that. We know that any object, okay, suppose the object may be gold, silver or wood or piece of stone, it is made up of a tiny particles which are indivisible. Okay, if you break, suppose this pen, okay, if you break this pen into a small particle, then what you will get? You will get the furthermost smallest particle which cannot be divisible into any other simple form. Okay, that type of particle is known as atom. It cannot be seen by our naked eye. So if we zoom the atom, then we can see that this is a aluminum atom. Okay, atom is made up of proton, neutron and electron. Proton and neutron are inside the nucleus. Okay, this is a nucleus, and electron will revolve in different cell or orbit around the nucleus. Now we need to understand that this aluminum atom have 13 proton and 13 electron. You can see here 2 electron here, 8 electron here and 3 electron here. 2 plus 8 is 10, 10 plus 3 is 13. Electrons have negative charge, proton have positive charge and neutron is chargeless. You can see there 13 positive charge is inside the nucleus and 13 negative charge are revolving in different orbit. So what happens? Positive charge tries to attract the negative charge. Okay, positive charge tries to attract the negative charge. Those charge which are near the positive charge, suppose here are 13 positive charge, here are 2 negative charge, so it can attract this negative charge. Okay, I want to tell that opposite charge always attracts each other and same charge always repel each other. Okay, we that is opposite of attraction. Suppose here are 13 positive charge, so these two negative charge can be easily attracted. This 8 negative charge can easily be attracted because it is very near to the nucleus, but these 3 negative charge, it is the in the outermost orbit. Okay, we call this as a orbit, as you consider this as a sun and these are other planet revolves in the orbit, so it will be easy to remember the electrons revolves in a orbit. So now we know that electron being a negative charge, proton being a positive charge attracts the negative charge towards it. So that's why in the process of attraction, some negative charge will not be attracted by the proton, so it will be free to move in this atom. So this type of free electron will help for the conduction of electric current. Okay, this electron cannot be free to move because it is bounded by this positive charge, but this 3 electron may be, okay, I am using the word may because in all the atom this outermost orbit electron will not be able to move, but these 3 negative charge will maybe move in as a free electron. So that's why this charge, this electron will be responsible for the conduction of electricity. So now this is the diagram of aluminum atom. So now I want to say something more about this atom. All atom are neutral. Okay, atom is electrically neutral because the number of positive charge will be equal to number of negative charge. Suppose in this atom we have 13 number of proton positive charge and 13 number of negative charge that cancel each other and altogether the atom will be neutral or chargeless. This neutron do not have charge, so this is also chargeless, and the overall result of proton and neutron, proton and electron is also chargeless. So now if we consider a electric circuit, okay, this is a conductor. Okay, as I told you that those atom, if it gives a free electron outside, then that type of atom is known as a conductor. Okay, conductor means it will be freely able to conduct a electron. Okay, it is a good conductor of electricity. If it do not give this type of free electron outside, that is called a insulator. Okay, insulator that behaves like a bad conductor of electricity. Now we are in this electrical circuit. This is made up of conductor. Okay, suppose aluminum, gold, copper. Okay, these are the good conductor. Now what even here is a negative and here is positive charge. This is a battery. Okay, as I told you before. Okay, electron moves from negative charge, and this is a conductor. Okay, made up of same aluminum. Let us suppose that example. Okay, suppose the electron is moving over here. That means those free electron are moving. Okay, that free electron helps to conduct the electron which comes from this battery. Okay, will be supplied to that aluminum. That aluminum hands over its electron to other, so that's why the electron will be moving in this circuit. So what even in the process of movement of electron in the circuit, we call that process as a current. Okay, that process is known as a current. Now how does a current moves in this circuit? Okay, suppose electron is here. Okay, it is moving in this direction. Okay, it is coming back to the positive charge. See, electron is coming from negative towards positive, because electron is negative charge. Negative charge will come towards the positive, because negative will be attracted by the positive charge. So this is the flow of current. Now how current flows in a circuit? That is all due to the voltage. Okay, current flows in the circuit due to voltage. Suppose this is a battery. We know that battery will be either 5 volt or 12 volt or 1.5 volt. Okay, whatever the battery, the source is there. Okay, in this process the light glows. Suppose, what do you mean by 5 volt? It is the potential energy which is given by the battery to drive, to move this electron in a circuit. That means with the help of voltage only, the current can flow in a circuit. Okay, if there is no voltage, electron will be still. Okay, it will not move. If as soon as you connect, this electron moves in a circuit, that is called a voltage. Now we have known about current, we have known about voltage. Now whenever we need to measure a current in this circuit, then what we'll do, we'll take a ammeter. Okay, there is a instrument, we call it as a ammeter. Okay, we'll place this ammeter in a series. Okay, we should understand the connection. Okay, for measurement of current we need a series connection, and for measurement of voltage we need a parallel connection. Suppose this is a ammeter. Okay, it is represented by letter A. Suppose from here the light bulb is there and the circuit is coming towards the positive charge. Suppose if you place the, if you break this circuit and place here a ammeter. Okay, so from here light, ammeter and positive terminal, then this type of connection is called a series connection. Suppose by this way, if you place any kind of thing, okay, from here this one and from here another bulb, the connection will be in series. Okay, for the connection will be in series. So this type of connection is preferred for the measurement of current. And how to measure the voltage? Voltage is measured by the instrument called a voltmeter. Okay, voltage is measured by an instrument called a voltmeter. Now for this we need a parallel connection. Parallel connection means what? If you have a voltmeter, one point will be connected with directly the negative one of a battery, another point will be connected with the positive one of a battery. So this type of connection is called a parallel connection. Okay, this type of connection is called a parallel connection. New, you can see here ammeter, it is connected with the positive, but this one is connected with the bulb. So this is not a parallel connection, it is a series connection. So by this way we measure a current, we measure a voltage. So what is the SI unit of current? Suppose if you measure a mass, okay, we call it as a kilogram, okay, this much kilogram. But if you measure a current, you call it as a ampere, okay, that is a SI unit of current. If you measure a voltage, you call it as a volt. It is represented by capital V, it is represented by a letter capital A. Now we need to understand a term called a resistance, okay. We need to understand a term called a resistance. Okay, what do you mean by resistance? Although my writing is not good, okay, I want to take a new paper. What do you mean by resistance? Okay, we know that our electrical circuit, okay, suppose this is a negative terminal and this one is a positive terminal, okay, one will be small, one will be big. Here is a light bulb. Okay, now what do you mean by resistance? All material, okay, material means any kind of object, tries to stop the current to flow in some extent. Okay, suppose this is an aluminum wire, okay, this is aluminum wire, this one is a voltage 5 volt, okay, battery, and this one is a bulb, okay. Suppose here the appliances are aluminum wire, okay, this one is aluminum wire, and this one is a bulb, and this is a again wire, it will be connected with the positive terminal of a battery. So what happen, suppose from here the electron flows, okay, from here the electron flows. That means the flow of electron is called a current. But due to conventional direction of current, we call the current is flowing from positive to negative. But here you imagine, okay, whenever the electron flows, then there is a flow of current. Otherwise, there is no any flow of current. I talked already. So this aluminum wire is a material, this bulb is a material. It do not allow current to flow easily. It tries to stop, okay, any material tries to stop the flow of electron or a flow of current in a circuit. That type of process is called a resistance. Suppose from here, okay, suppose from here, it is said that 5 ampere of current is flowing, suppose, okay, 5 ampere of current is flowing. Then what I mean, here are many wires, okay. This, although aluminum is a good conductor of electricity, it means that its resistance is very low, okay, resistance is very low. That means over here you can get around 4.999 ampere. That means something ampere is lost, because it is providing a resistance, okay. Any material provides a resistance. Some material will be giving higher resistance, some material will be giving lower resistance. Now the value of, what is the meaning of using resistance in a circuit? The meaning of using resistance in a circuit is to decrease the level of current, okay. In a market you can see the artificial resistance, okay, whose picture I'll place in this place in a video, okay. You can see here in the upper side the logo of aluminum or resistance, okay, that is a resistance, and that helps to stop the flow of current in a circuit. Suppose if you keep here a resistance, okay, this is a symbol of resistance like ammeter. If you keep here resistance, then what even from here 5 ampere of current is flowing, and over here you can get 4 ampere, or you can get 2 ampere, or you can get 3 ampere, okay. This type of substance is called a resistance, which decrease the flow of current. Now let us understand the voltage. Voltage is pushing electron, but resistance is stopping the electron to flow, okay. That is the relation between voltage, moving electron is current, and resistance is stopping current to flow through it, okay. Less amount of current will be transferred to the other side. So this type of connection is known as a resistance, voltage, and a current, okay. Suppose in a technical term, resistance is denoted by a letter R, voltage is denoted by a letter V, current is denoted by a letter I, okay. A means the ampere, okay, that is the unit of current, but that is I, okay. Current is represented by I. Suppose mass is represented by small m, okay, and its unit is kg simply, okay, don't be confused. Suppose what is the relation between these three? its relation is V is equal to IR. This is called a Ohm's law. Okay, it is called a Ohm's law. Suppose from here I and R are multiplying each other. If you take R on the other side, it will be V by R. It will divide. Okay, I is equal to V by R. That means if a current increase, then the resistance decrease. Suppose here 5 ampere, here also 5 ampere. Current is not decreasing. That means current is same. That means at that case the resistance is very low. If the resistance is high, if you are bringing a huge resistance of something 100 kilo ohm, then what happen? Current will be low. If resistance high, current will be low. And what is the relation between voltage and current? That are directly proportional, up, no, this one is up down, so this one is up. If voltage increase, current also increase. If you keep your 12-volt battery, more amount of current will flow in a circuit. Okay, this is the simple explanation of a. Thank you very much for viewing this video. Today we have learned about voltage, resistance and current from the basic detail. Okay, I hope it solves your queries, it solves your doubts. So if you have anything, okay, regarding this video, if you want to give any kind of comment, then the comment section is open for you all. Okay, we'll meet again. I'm taking goodbye from today's session. Bye bye. Current, voltage and resistance. Okay.